Hello friends, in this video I'd like to solve the following problem from the Romanian District Mathematical Olympiad for 9th graders 2024, problem number 1. Let ABCD be a convex quadrilateral whose diagonals intersect at point S. We wish to prove that ABCD is a parallelogram if and only if AB plus AS plus AD vectors, that is, equals vector BC plus vector SC plus vector DC. It's an interesting problem. Here are my hints. First, showing that if ABCD is a parallelogram, then our equality holds. Well, this implication is very easy. But second implication is harder. To prove that if our vector equality is attained, then our figure is a parallelogram. Suppose that AB plus AS plus AD equals BC plus SC plus DC, and consider point C prime be the point such that AB C prime D is a parallelogram, and let S prime be the point of intersection of diagonals AC prime and BD. Now, show that points AC and C prime are collinear, and deduce that S must be equal to S prime, and then try showing that C prime vector C prime equals the zero vector, which means that points C and C prime coincide, and our figure is ABCD itself is a parallelogram. And by the way, in the original problem statement, only the second non-trivial implication was asked to be proved. So give this problem a try, and I will see you in just a minute. Alright, so let's start with first part. First implication is very easy. So first implication, part 1. Let's suppose that ABCD is a parallelogram. As indicated, as drawn to the right. Now, let's take a look. Then we have the following equalities. Vector AB equals vector DC. What else? Vector BC equals vector AD. And finally, if we draw the diagonals, well, S is in the middle of segment AC, so vector AS equals vector SC, which after addition gives us the vector AB plus vector AS plus vector AD equals vector BC SC DC. So it's the end of the proof in this direction. Now, second part is much more interesting. Now let's suppose that we have our convex quadrilateral ABCD, and now consider point C prime. Consider C prime such that AB C prime D is a parallelogram. And S prime, let S prime be the point of intersection of the diagonals AB or AC prime and BD. Now, I claim several things. My first claim number 1, I claim that points A, C, and C prime are collinear. As indicated in my drawing. Let's prove it. Proof of my first claim. How can we prove it? Well, remember that we assume that AB plus AS plus AD equals BC plus SC plus DC. It's our assumption. And what I will do, I will add on both sides AB, I will add AS, and I will add AD. So, on both sides. Alright, and now let's take a look. On the left-hand side, we have 2AB plus AD. We have plus 2AS, and we also have BC. Let's take a look. What is AD plus DC? Or maybe AB plus BC? Well, AB plus BC is, of course, vector AC. Yes? AB plus BC is the entire vector AC. Likewise, the second vector AS plus SC is also AC, and the last pair of vectors is also AC. So, we get the following: 2AB plus AD. Let's put AS on the right-hand side, and we have 3 times AC minus 2 times AS. Alright, and now after division, and now also notice what is AB plus AD? Well, according to the rule of vector addition obeys the parallelogram rule. So if we add AB and we add AD, we get a parallelogram. So the result is AC prime. So 2AC prime equals 3AC minus 2AS. And after division by 2, we get AC prime equals 3 over 2 AC minus AS. Which means that this, and notice now that what? Let's take a look at our parallelogram. This vector lies on a line connecting points A and C. Lies on the line AC. So this vector must also lie on this very line. So it implies that C prime lies on the line AC, which of course means that our points are collinear, which closes the proof of my first claim. Very well, my second claim, I claim that points S and S prime coincide. So the point of intersection of AC with BD is the same as the point of intersection of AC prime and BD. Proof is very simple, once again, because proof S, maybe let's write it in our notation, in set theory notation. Set containing S is the point of intersection of segments AC and BD, but also this is exactly the same. Since our quadrilateral is convex, it's the point of intersection of line AC with line BD. But line AC, well, it's exactly the same as line AC prime because they are collinear. So it's AC prime intersected with BD, and this point of intersection is by definition S prime. It's by definition S prime, which means that S equals S prime. And my last claim I claim that not only S equals S prime, but C equals C prime as well. Proof of my last claim. Let's take once again our assumption. Remember that we assume that A B plus AS equals AD equals BC SC plus DC. It's our assumption, but now let's also notice that this S equals S prime, or maybe it's our assumption, but also by our first implication, by part 1, AB plus AS prime plus AD equals BC prime S prime C prime plus D C prime. Alright? So it's result of part A. Result of part 1 rather. And this is our assumption. And also, let's take these two equations and let's subtract them. After subtraction, or rather we can infer, maybe let's write it like that BC plus SC plus DC equals BC prime plus S prime C prime plus DC prime. Alright, and now let's do several things. On the left hand side, let's write BC as BC prime plus C prime C. Let's write SC as SC prime C prime C. Let's write DC as DC prime C prime C. And here we have BC prime. Now, result of claim number 2, S prime C is the same as SC prime, because of these 2 points coincide. And what do we have? BC prime cancels, SC prime cancels, DC prime cancels. So we are left with 3 vectors C prime C equals the 0 vector, which means that C prime C equals the 0 vector, which means that C equals C prime. And as an immediate corollary, well, since C equals C prime and ABC prime D is a parallelogram, ABCD itself is a parallelogram. And this actually closes our proof, because it is what we wanted to demonstrate. And that is it. So thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.